My job here today is to present the soil quality test kit, and we are really privileged to have one of the people who designed, the original people who designed the kit for us, to help us be able to find out how our soil works for us. We all have property somewhere. We buy either a home, or we buy a farm, we buy a ranch. But the question I want to ask you, and the question that this soil quality test kit is going to respond to, is how is your soil working for you? Are you satisfied with your soil? Is it working for you? How many of you think your soil has a problem? How can you tell? Plants don't grow? Okay, what else?
Or like George said earlier, up there on the ridge, it's blowing away from you.
Okay, that's right. So this kit was designed to answer some of those questions. And when you get your kit, it's going to come in a box like this. So when the UPS delivery man shows up on your driveway, or when George shows up, he'll be delivering something like this. That's so cumbersome, and it's so big that we felt like, no, we can do something about that. Okay? So, but what does it contain then? The components of the kit has about 32 different components. We can divide these components into three main groups. The components that we use for soil physical properties, those that we use to determine soil chemical properties, and those that we use to determine if the soil is alive. How do we determine if anything is alive at all? What are the characteristics of living things?
Breathing.
They breathe, all right? What else?
Reproduce.
They reproduce, okay? Okay, that's fine. So they breathe and they reproduce. So we've got equipment out here to determine if the soil is alive, right? So if you want to figure out if the soil is alive, you want to find out the number of people or the number of a certain population, the kinds of organisms of a certain population, how many are there within the soil? How much are they breathing over a unit period of time? How much carbon are they burning up? Those kind of questions we can answer. And you can determine whether that's good or bad for the purpose you're using the soil. So there is no one soil quality that fits all. Soil quality is based on the intended use of that soil. Okay, for the short time I got left, I'm going to invite people once in a while to help me to do these quick demonstrations about the different components of the soil quality test kit. First, we'll start with soil physical properties. Okay? So in your kit comes with a kit guide, soil quality test kit guide, and this comes with every kit that you purchase. Okay? Within this soil quality test kit guide, you have instructions for the different tests. You have about 12 different tests that were selected to meet the needs for, mostly the needs of farmers. And this, again, we divide into physical, biological, and chemical. Now, on the back part of the kit, we have the interpretations and some background information for each test. What do the results mean? I had a soil bulk density of 1.1. My neighbor had a soil bulk density of 1.5. So what? So what does that mean? It's more better? So those kind of things, I mean, you get in the interpretation. Okay. So, but to study soils, we talk about physical properties, chemical and biological, and there are simple things you can do without a kit at all. If you have a soil, you want to study that soil, there are things that you can do just by visual observation. What are some of the things that you can check out just using your senses? The smell. Well, so what does smell tell you about a soil? Oh.
You know, when the water can stand there forever,
Oh, that's right. Okay. How about your sight? A dark colored soil probably has more organic matter, except you live in Texas somewhere. Okay? What else? has the soil got some structure to it? How deep is the soil? Okay? So you can make certain observations without the use of a kit. But once you have this kit, you can quantify some of those observations. And that is the difference between just visual observation and the value of the kit. Okay, so when I go out, most often, I don't want anyone to ever undermine the power of the shovel. Okay, so when I take a shovel and scoop out a piece of soil, or a sharpshooter, I bring out that soil, I can check the structure, I can smell it, I can feel the texture, okay? I can tell whether it's sandy or it's, it's silty. All those evaluations are really critical. I can tell how much moisture is in there, how much clay is in there, by see if it forms how long a ribbon it can form, different moisture content. So all these are valuable tools that we use for evaluating soils. You also have your probe, which they mentioned earlier. So for right now, I want to concentrate on the physical properties. There are 4 basic tests that we can use this kit for in order to quantify. One, infiltration. What does infiltration mean? Anybody? Okay. Is that how water moves within the soil, or how water moves into the soil? Okay, how water penetrates the soil. So that's infiltration. Now, if your soil is infiltrating very slowly, is that a good thing? No. If it is infiltrating very fast, but why? So it depends on how you're going to use that soil. If you have a septic tank, say, if you want to build a septic tank, would rapid infiltration be good for you? Okay. All right. Now, if you have a situation, if you're a farmer and you have a soil that is infiltrating very fast, what does that tell you? Okay, it's a lot of sand in it, and you're not going to use that moisture because it's going into groundwater very quickly. So all these things give you a way of evaluating your soil and how the soil is working for you. So to measure infiltration, we use we cut an irrigation pipe. This is about a 6-inch ring out here, and we measure about 444 cc's of water. And once you pour this into this particular ring, the way they designed it, it gives you a 1-inch head. Now, how quickly does a 1-inch head disappear? That gives you your rate, right? So if 1 inch disappears in 15 minutes, I know 4 inches would infiltrate in an hour. So I have a rate of about 4 inches per hour, okay, which is pretty high, pretty significant. So in some soils that are really clay, that may be a lot slower. So that is how we determine our infiltration. And how do we do it? You take the ring, pound it into the ground using, and when you're pounding it, make sure that it doesn't wobble. All right. And once it's in there, you can measure the height if you want to be very, very accurate. And thereafter, you calculate your rate. The other thing we want to mention would be the bulk density. The bulk density tells you how much soil is contained within a unit volume. We're talking about a dry soil. How much dry soil is contained within a unit volume? So the mass of dry soil within a unit volume is a bulk density. Now, to do this practically, you need to measure the mass of the soil, and you need to determine the volume that soil occupied in the field. So this is a ring that we use to determine bulk density. Again, you take it, place it on the ground, you scrape the surface vegetation, make sure it is even, and then you pound it using our favorite wood block. You pound it to any height you want, depending on your soil. If it is real clay, you won't go very deep because it will be hard to pull out. And then your trowel comes in, you dig on the side very gently till you can remove the soil. You use a knife, slide it even, and then we've got a tape measure somewhere. You take the tape measure and you measure the height, and you subtract that from the bottom to find out the height of your soil. So that's your soil, the volume your soil occupied in the field. You take that sample, put it in a bag, put it in an oven, and you dry it, or you can air dry it till you get a constant weight. So your sample is out here. You can put it in a paper plate and put it in an oven. I didn't suggest putting a plastic bag in an oven, but you do that for about 24, 48 hours, and then you get a constant weight. You find the difference. Now, what are the components of soil? We know soil would contain what? Organic matter. It will contain mineral matter. It will contain some pore space, and that pore space can be occupied by what? Air and water, okay? And that will depend on how long ago it rained. It depends on the type of soil. Right, so we can use that information to determine the amount of water that was contained in a given mass of soil or in a given volume of soil. So you can measure your water on a volumetric basis, or you can measure your water on a gravimetric basis. And all this provides opportunity for your students to do some calculations, right? All the math, additions and subtraction and multiplication that they learn, they can apply that, and that enhances their knowledge. And fortunately, with folks like Dr. Duran and others, they can get paid for it. These are clear examples of people who have made a good living because they studied the land. Okay, so we've seen infiltration, we've talked about bulk density, we've talked about moisture content. What did I forget? Let's see. Okay, we got one more. We got aggregate stability. This tool is a test that is pretty complicated, but we're going to see a demonstration that Mike is going to do later on today that shows you how to determine whether the soil can hold itself together or whether it disintegrates under, when it takes up water or when water is applied to it. But this little kit has some small screens on them, and what we do is we take them and then we'll put some water in this one, and then you take a small aggregate, place it on the screen, and you dip it, about 5 times, 6 times, and you find out how much of the aggregate stays intact. That tells you how stable that aggregate is. So there are ways that help you determine whether it's very stable, the number of dips before it disintegrates and all that, and then you can measure the difference between what you had before versus what you have now after dipping it 6 times. So that tells you how stable the aggregate is.